Alright, in this video we're going to figure out how to find the exact value of the tangent of 255 degrees. That's the first thing that's bothering me. This is in degrees. I'd much rather have it in radians. So let's make that conversion. The way we convert degrees into radians is we multiply by pi over 180, which basically means I'm going to put a pi next to it and 180 under it. Now, Jordan, if I divide both of these by 5, what am I going to get so far?
You get 51 over 36.
All right, so now I have 51 over 36. Now, both of these are divisible by 3. So do that and tell me what you get.
17 over 12.
Okay, so I have 17 pi over 12. So far that's what we have. So this problem can be rewritten as the tangent of 17 pi over 12. Now this is not a special angle, so I need to split this up into two angles that are special angles. So one way of figuring out how to break this up into special angles is to subtract a special angle. So I have 17 pi over 12. Usually it works to just subtract pi over 4, so I would start with that and see what I get. To subtract these, I would need like denominators, so I would multiply by 3. So that's 17 pi over 12 minus 3 pi over 12, so that's 14 pi over 12. That reduces down to 7 pi over 6. So now I have 17 pi over 12 minus pi over 4 is equal to 7 pi over 6. That means 17 pi over 12 is equal to pi over 4 plus 7 pi over 6. So I'm going to make that substitution now. So now I will think of the problem as the tangent of pi over 4 plus 7 pi over 6. Now, looking at our sum and difference identities, this is the formula for the tangent of a sum. So hang on to that in your brain. So if I apply that formula to this, then I have tangent pi over 4 plus tangent 7 pi over 6 over 1 minus tangent pi over 4 tangent 7 pi over 6. Okay, now tangent of pi over 4, that's 1. That's just one of those values that we've memorized. Tangent of pi over 4 is 1. Tangent of 7 pi over 6, I'm thinking about the reference angle pi over 6. So I know that the tangent of pi over 6, we've memorized that to be radical 3 over 3. So the only question is, should it be negative radical 3 over 3? For that, we just consider the quadrant that it's in. And so if I think about my pi over 6's, I'll just draw my little bootleg diagram. That was just too horrible to count. Try that one more time. Alright, here's my little pi over 6 diagram. Okay, so I have these 4 angles to consider that all have a reference angle of pi over 6. 2 of them will be positive and 2 of them will be negative. Okay. Well, actually, I don't care about all those. The 7 pi over 6 is in this quadrant right here, so that's going to be positive. Okay, so now in the denominator, I have 1 minus. We've already discussed that the tangent is 1, so I'm just going to ignore that. And again, I'm going to have radical 3 over 3. From the tangent 7 pi over 6. Okay? Does that make sense so far?
Yeah, I've gotten that.
Okay, so now I'm just going to add the numerator terms together, and I'm going to add the denominator terms together. One way to do that is to understand that 1 is really 3 over 3. So both of these problems will become, will have a 3 over 3 where the 1 used to be. Okay, so now I'm in a good position to add these up. Get rid of this. Okay, so I'm going to have 3 plus radical 3 over 3 over 3 minus radical 3 over 3. Now, I'm noticing that these denominators are the same, the 3 and the 3. So I know those will just cancel out. So that's going to give me 3 plus radical 3 over 3 minus radical 3. And that is going to be your final answer. Okay, number 2. Keeping in mind that our special angles are 30 degrees, 45 degrees, and 60 degrees. Is there a way that I can write 75 using 2 of these numbers? Yes. 30 plus 45 is 75. So I could write this problem as the cosine of 30 degrees plus 45 degrees. Now, the formula for the cosine of a sum, in my mind I always say cosine, cosine, and then sine, sine. So this is going to be cosine of 30, cosine of 45, minus, because it changes signs for when it's cosine, and then sine, sine. So sine 30, sine 45. And we've memorized these values. The cosine of 30 is radical 3 over 2. And the cosine of 45 is radical 2 over 2. And the sine of 30 is 1/2. And the sine of 45 is radical 2 over 2. And again, this is the chart of values that we memorized way back during Unit 1. Just make sure you still have this information in your brain. And pi over 4 is the same thing as 45 degrees, pi over 6 is the same thing as 30 degrees, and pi over 3 is the same thing as 60 degrees. Anyways, if I multiply this together, I'm going to get radical 6 over 4 minus radical 2 over 4. So that gives me radical 6 minus radical 2 over 4. And that is the final answer. There's that 75 again. So once again, this can be written as tangent of 30 plus 45. So the formula for tangent goes like this. Tangent plus tangent over 1 minus tangent tangent. Okay? Notice that in the numerator the sign is the same, but in the denominator the sign is the opposite. And we have all these memorized. So the tangent of 30, that is radical 3 over 3. The tangent of 45 is 1. Okay, and again, I'm just pulling all of this off the chart. Tangent of 30 is radical 3 over 3. Tangent of 45 is 1. All right, now down here in the denominator, I have 1 minus, and again, the tangent of 30 is radical 3 over 3. And then the tangent of 45 is 1. But anything, if I multiply by 1, it's not changing anything. So I don't really need to write down the 1 that comes from the tangent of 45. So I'm not going to put it. Now, I need to have like denominators so I can add these together. So instead of having a 1 is really a magical number because you can write a 1 as like 2 over 2 or 3 over 3 or whatever you want. I'm going to replace that 1 with 3 over 3 so that I have like denominators. So that will enable me to put these together. So all right, here's my big old fraction bar. So looking at the numerator, I have radical 3 plus 3 over 3. Looking at the denominator, I have 3 minus radical 3 over 3. Notice that the denominators are the same. So when the denominators are the same, you can really cancel these out. So these are gone. And that's going to leave me with radical 3 plus 3 over 3 minus radical 3. Okay, so that is the final answer. Okay, you're probably more likely to see this written as 3 plus radical 3 over 3 minus radical 3. This is more common. For problem number 4, looking at the cosine of 15, how can I get the number 15 by either adding or subtracting 30, 45, or 60? Well, there's more than one way to do it, but one way is 45 minus 30. So this would be the same thing as cosine of 45 minus 30. So the cosine formula, it goes cosine, cosine, sine, sine. So cosine 45 cosine 30 plus sine 45 sine 30. All right, when it's cosine, it changes to the opposite sign. Now, we have memorized all of these values. So cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Sine of 45 is radical 2 over 2. And sine of 30 is 1/2. So that's going to be radical 6 over 4 plus radical 2 over 4. So the final answer is going to be radical 6 plus radical 2 over 4. All right, for number 5, we are switching over to radians, and there's a little technique that I like to use that helps me decide how to split up 11 pi over 12, for example. And here's what I like to do. I will start with the original angle, 11 pi over 12. And then I will subtract pi over 4, all right, which is a special angle. And then I want to see what I get. I need like denominators, so I would have to do 3 over 3. So 11 pi minus 3 pi, that's going to be 8 pi. So 8 pi over 12. So this is the same thing as having 11 pi over 12 minus pi over 4, or I'm just putting it back to its simple form. And I will also reduce this. Let's see, these are both divisible by 4, so this will be 2 pi over 3. Now, I need to get this by itself so I can see what this equals. So I'm going to add pi over 4 to both sides. So that makes this 11 pi over 12 is equal to pi over 4 plus 2 pi over 3. So this is what I will use to substitute for 11 pi over 12. So this original problem can be rewritten as the sine of pi over 4 plus 2 pi over 3. And the sine of a sum formula goes sine cosine plus cosine sine. So this will be sine pi over 4 cosine 2 pi over 3 plus cosine pi over 4 cosine 2, sine cosine cosine sine. I got carried away there with the cosines. So sine 2 pi over 3. All right, these are all values that we have memorized. The sine of pi over 4 is radical 2 over 2. The cosine of 2 pi over 3. Well, look, let me think about this off to the side for a second. When I talk about the cosine of 2 pi over 3, the reference angle, of course, is pi over 3. Okay, so I ask myself, what is the cosine of, I put a 13. What is the cosine of pi over 3? The cosine of pi over 3 is 1/2. That means the cosine of 2 pi over 3 is either 1/2 or it is negative 1/2. Now, the way I will know whether it's positive or negative is based on the quadrant. All right, 2 pi over 3. All right, I'm picturing this in my mind. Pi over 3's look like this. So 2 pi over 3 is right here. That's in the second quadrant. Cosine is negative over here. Okay, so that tells me that I will have negative 1/2. All right, you should be able to do all that in your head though. So this is negative 1/2. Cosine of pi over 4, it's back to radical 2 over 2. Sine 2 pi over 3. Again, the reference angle is pi over 3. The sine of pi over 3 is radical 3 over 2. The only question is, will it be positive or negative? Well, again, in this quadrant, the sine function is positive because it's a y value. So I'll just leave it like this. Okay, so now I can go ahead and finish solving the problem. So this is going to be negative radical 2 over 4 plus radical 6 over 4. So when I put these together, I will probably write it as radical 6 minus radical 2 over 4. I just think that's a little bit cleaner than having negative radical 2 plus radical 6. I like this better. Okay, problem number 6, the tangent of 7 pi over 12. First, I need to figure out how to break this down. So I'm going to start with 7 pi over 12, and I'm going to subtract pi over 4 from it and see what I get. So of course I will have to multiply by 3's in order to get like denominators. 7 pi over 12 minus 3 pi over 12 is going to be 4 pi over 12. So that means I have 7 pi over 12 minus pi over 4 is equal to, this is pi over 3 once I reduce. So now I'm going to add pi over 4 to both sides, so that's going to give me 7 pi over 12 is equal to pi over 4 plus pi over 3. So this is what I can use to substitute for 7 pi over 12. So problem number 6 can be rewritten as the tangent of pi over 4 plus pi over 3. Now the tangent sum formula goes tangent plus tangent over 1 minus tangent tangent. So this is going to be tangent pi over 4 plus tangent pi over 3 over 1 minus tangent pi over 4 tangent pi over 3. So I know the values of each of these, so I'm just going to substitute. The tangent of pi over 4 is 1. The tangent of pi over 3 is radical 3. The tangent of pi over 4 is 1. Tangent of pi over 3 is radical 3. So I'm not writing the 1 that comes from the tangent of pi over 4, because if I put a 1 right here, 1 times radical 3 is still radical 3. So it's not changing anything, so I can just skip it. And guess what? That's going to be the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.